Okay guys, so for today class we are going to talk about linked list. Linked list is just a data structure, right? What is data structure? So until now in our JavaScript, we learned about string, number, boolean. These are the data, right? Null, undefined. The way you store your data, you arrange your data, right? That is data structure. So we have array and object, correct? Array and object. Array is the built-in data structure inside the JavaScript. So in array, right? Array, how we store data? You have the just in the sequence, right? Just imagine this is the memory box, one variable called array, right? ARR. That's the variable, right? ARR. Oh, where I can make it small. Let's see. ARR, right? This is the variable, simple variable equal to this one. So here you store the data, right, one by one. So this is 1 2 3. You can add here any type means number. Type of data is what? Number, string, boolean, even array itself, object, anything you can store here, right? You can even put object you can put here. Okay, so this is how you store the data. Now if this is the array, right, you remember all the methods of array. So you can insert in the front, right? You can add here unshift, shift, remember that, from the front. Back here push and pop, right? So push will be to add data in the array in the back, okay, the last one, right? And there is pop to remove, pop, right? And there was shift and unshift from the front. So more like if, right, if I ask you add data here, this is the index 0 1 2 3 4 5 6 whatever 7, right? For example, this is always fixed. Sometimes you create an array of, let's say, 100, right, and you have only stored the data in 20. Now the remaining fields are empty, but it still takes memory space. Okay, that is useless, right? Like adding and popping, right, from the front and back is easy here. Like it will not take time, it will not gonna take time, right? But for example, if I ask you to add something in the 4 index here, right, how are you gonna do that? Now just imagine, right, you have information here also, like maybe 5 something here is already. Just imagine, right? Now if we need to insert something here, that is insert, or maybe remove, right, from here, you need to add something on the last and then move the 8 here, 7 here, 6 here, 5 here, and the new data will be here, right? See that? So the n is order of n. You have to move n times, you have to move something n times, then only you'll be able to insert. So the inserting data in the middle of the array is what you call that, difficult, right? Or maybe expensive. Just remember that. So that is our data structure in array. You have to learn. I mean, we have learned a lot in the array, right? You have solved a lot of problems, remember that. But still there is more advanced concept in array. But just remember as long as you know the basic of array, that is okay to do the job, right? Normally until now, right, we have done array and there will be object, and you loop through the array and you getting each object and displaying in your page, correct? That is what we have done until now, right? MongoDB data structure and all that we have done same thing. But in a advanced topic, right, for the interview, sometimes when you not now, right, what we're going to learn is maybe will be not useful in your project anyway, you're never going to use, okay? But in the interview they normally ask, right, if the student know how to create a linked list. Okay, so what is a linked list now, right? Because if you know how to add linked list, means you have idea on creating the class constructor functions maybe, right? Creating the nodes and putting that together, right, in form of some kind of data structure. Even if you know the linked list, you can use linked list to create maybe stacking or let's say queue, some kind of other data structure. You can use this one to implement that also, right? There is possibility, okay? But today we just understand simple linked list and that is all. So let's talk about linked list. A linked list is one data structure you should know, right? If you do not really understand it or how it implement in JavaScript, this article is here to help you. Okay, we will discuss about linked list here. What is linked list now? What is a linked list? A linked list is a linear data structure similar to array. Similar to array, okay? However, unlike array, elements are not stored in a particular memory location or index. So in linked list, we don't store the data in the index format, okay? We don't store, and we'll see why, right? Rather, each element is a separate object. So each, here is the important point now, each element, right, means each data is a separate object that contains a pointer or a link to the next object in the list. Okay, so I will put examples and then understand this part. This is the important concept here. Each element, commonly called node, right, node, contains two items: the data stored and the link to the next node, that is same above. The data can be any valid data type, right? So data can be anything, like it can be number, boolean, array, object, anything, okay? You can add there, right? You can see this illustration in the right diagram below. So look at here, right? This is the starting node, that is, it has a 6, and then it has the next like link, right? Next link to the next node, that it has, next node has 10 data, the next has 12, and next has 3, right? And there is a null now. Null, the last is pointing to the null, the first one is pointing to the head, right? Head. So there will be always head and there will be always null, right? The last, when you find the null, that means your node, there is no more node, right? Starting point will be head, because we have to start from somewhere and get somewhere, right? So let's take this one now, see how it looks. This is a variable, correct? That's the object, right? The big object. So linked list is what? It's just a combination of node, right? Lot of node put together. It's an object, which each object is one node. Okay, so what that means is, if I have, this is the first one, right? First one, and let's say it has the value 5, okay, and here is the pointer, right? Let's call it P or next, whatever. This is the first one, so this must start from head, right? I mean, this is the name, okay? Starting point, we call it head, right? Head. Right now it is pointing to the null. So the last, there is, after that, if there is nothing, then it is null, right? Null, okay? So this is just a diagram. What is that exactly? That is a object. So we can call it head, right? And this is the object, and it has the value, we can call it value is 5, and pointer, there is a pointer is right now null, right? Null, because it is pointing to the null, nothing there. But if there is new node, right? Let's say if you have a new node, let's say it has a value 6, and and that there is a pointer also, correct? So now the head has a value 5 and P is a pointer, so this pointer is pointing to the new node that has a value 6, and the pointer right now either null, if there is nothing then that will be null. If there is a new node, same thing now, same process. Let's say 7 and then a pointer that is pointing to the null for now. Let's think about that, right? So that will be pointing to null. Okay, so we have 3 element, right, in our linked list, 3 element or 3 node. So I can delete that. Just imagine, right? So, and then finally this head is closing here, right? Head is closing here, and also it the first one, yeah, that is head, right? So the head, this one, basically 1 2 3. We have to somehow, you have to get 3, right? So okay, so somehow we have to make it 3 object, because starting here, here and here, right? So that's how it is created, right? Linked list is created in this way, okay, in this manner. So if you look at the important point, the object is the important, right? You have to create an object for each node. So now you remember how we create object in JavaScript in the object oriented constructor function, or you can use class or maybe constructor function, right? So we're gonna look at that in the when we write a code. So see here, head, it has the value 6, and the pointer is the next, right? Next object, okay? So it has, next one has value 10, and next is pointing to the next object again, that has value 12, and next is pointing to the next object that has value 3, and the final is null. See that? So it closes here, that is closing here, and that is closing here, and head is closing to the end, and final is the object, right? The list object, list. So this is the object format of the linked list, right? Linked list. So now the thing we're gonna learn, right? Okay, so there is an advantage of the linked list, a disadvantage of the linked list. Node can easily be removed or add from the linked list without reorganizing the entire data structure. Okay, advantage, right? So if you want to add something here, maybe index, let's say 0 1 somewhere here, right? So you don't have to move all this here. For example, let's say you want to add something here, right? Maybe before this one. So let's say there is hundreds of node, you don't have to move that. What it does, right? Basically the next here, see, this is the pointer, right? First you have the new node, you're going to create a new node, you're going to point to this node, this pointer will point here, right? And this is also pointing here, correct, like this. So once you point here, right, this pointer, you point this one again, you can do that, right? Done. So this will be already in the middle now. So this is start here, let's say 20, and next pointer, whatever pointer here. So so you just need to change the pointer, make a connection, right? Pointer, add somewhere, and then done. Removing is same thing, okay? So that's why it's in that way you don't have to move everything like array. You don't need to do that. That is what he's saying, right? Node can easily be removed or add from the link with list without reorganizing the entire data structure. What is disadvantage, right? Search operation is very slow in linked list, unlike array. In the array, right, if you know the index, you can find any element easily from the, if you have, let's say you know the index 10, array square bracket 10 will give you that element, right? So search in array is very quick, but in linked list, how you gonna search? Again, you have to start from the head, right, and then keep moving each item, okay? Keep checking from start from head and then until the last, right, to find your information. So that is time consuming. It use more memory than array because of the storage of the pointer, right? Okay, so there is the data and the pointer, that means it's taking more memory. So there are 3 linked lists: single linked list, singly, doubly, circular, right? So today we're just going to look at this, but just remember there are different types of linked list, three different. Singly linked list, singly linked list is what we say one pointer, right? But in double linked list, even you pointing to the, you pointing backward and forward both way, okay? So that is how it work in the double linked list. Circular will be, I think, you start from last, right? And then the last one will be pointing to the first one also. So that's the circular linked list. But when you construct, then you're gonna figure out, right? So let's implement, right? Let's implement this, okay? So implementing the list lead, implementing a list node in a JavaScript. So there will be list, linked list, and putting all together, right? So yeah, so this is the new node, okay, fine. And then so yeah, so I mean, okay, so you can link list in the method, right? Size, clear, get last, get first, you can do all that things. Okay, let's implement. Okay, the first one, I have written the code here, so we'll just take from there. That will be better. It's long, okay? There will be long code, but we're gonna start from. So first we're gonna create the class, right? Class or constructor function for creating a node. Okay, so let's look at that. So we can call the link, maybe list or node, whatever you can call. So just copy this and go back here. So what this does, right? Constructor function, you're gonna pass the data and it will return the object, correct? So let's verify this. Okay, so const, let's call it node1, right, equal to new. So when you have constructor function, how we create the object, adding the new, right? Remember, new node, and let's pass the data 10, right? So you pass the data and see, every object is going to have two property, right? The one will be data and the next one will be the pointer, next pointer. So let's verify this. Console.log and node1. So let's run this code. So look at here now. Now your node is this is the first object. So every time when we create a new node, you're gonna call this, right? You're gonna call this one. This constructor is to just creating a node, okay? You're gonna get object like that. So there will be data and the pointer. So right now pointer is null, but later this pointer is going to point to the next node. What is node? Node is a object, JavaScript object. So it will later, right, when you, it will just form this format, okay? It will just be formed in this format. So if you understand this part, then it will help. Okay, let's move, right? So we know how to create node now. I will delete this. So the next one is, now start our linked list, right? Linked list. So just copy this one. Okay, fine. So copy this. So we started the new constructor function. It must be close, right? Close. So we're gonna do, now we're gonna add all the functionality, like how you're gonna add new data to your linked list, how you're gonna, when you insert, right? So see how many operations are here. Adding to the beginning of your linked list, add at the last of the node, right? A beginning of your list, maybe beginning of the list. How you're gonna add to the last of your node or list. Then you're gonna say find the size of your linked list, size, right? So in array we have array.length. So here also we need a size, okay? We're gonna find the size. How are we gonna find that? add at the certain point, right, or index. So maybe if you want to add your node to certain point, within the middle or maybe last or in wherever, right? So how you gonna do that? That is the one operation. So these all are these are the different operation, right, you can do in the linked list data structure. The next one will be remove from the node, from the first of the node, right? So it's remove from the beginning, that will be from the head, right? And remove from the last node, then remove at the at certain index, right? Maybe somewhere in the middle, right? Remove there, or anywhere in the any index, okay? Remove from the index. What else is there? Okay, print, right? So how are you going to print your whole list of linked list? So these are the few, I think 6-7 functionality or operation we can call, right, to your linked list. So once you have all this functionality built, right, then we're going to create our object, and then we're going to test all our function, right, like adding, then remove, then add at certain index, remove the last, remove at certain index, then print the linked list. Okay, so this is what we're going to do. So let's look at the first functionality now, right? This is the linked list. So normally if you go back here, right, let's say let, what name I have given here. So let's call this yeah. So what I have done is basically from this constructor function we create the new instance or new object, and now if you console log, right, console.log linked list, what we get, we're going to get one object, and that's going to have a head, right? Start with the head, because remember what I said, and that pointing to the null, right now head has no data, so it is just pointing to the null. So let's look at, see how it looks now, right? So look at here, the head is the object, this is just the object with the head property and pointing to the null, correct? So now in the head, right, we're going to add the new node, we're just going to add a node with the data and the new next pointer. Okay, so that means first our function will be adding in the beginning. I think that is what there is, right? Let's check. Add first. Okay, so I'll copy this, I'll just take all this. Did I copy? No, right? So see, this is the constructor, right? Constructor function. Now inside here you can add all the function you need for this, for this instance to have access, right? Add. So what you're gonna do, this is a function, add first, and this function will ask you the data, right? So maybe you're passing 10, let's, for example. Now you have a data, so you need to create the node now, node. So remember how we create node? We have this constructor function already. So we say new node constructor function, and this function is asking you the data 10, 20, whatever, right? So that is coming from this data here, data. Okay, so we get a node now, right? So here what you will get, you're gonna get the data and the next pointer, you're gonna get that object. Okay, so that is what the new node object, and we seen before, right, the object and how you create a node and all that. Okay, so this new node has the, the next pointer, right? New node dot next, see that this node, when you call this constructor, we have this object, right, like that. Okay, so let's check here, and then let's create, let node 1 again, right, and new node and pass 10. Okay, and console log. log node 1, right? Then it will be clear. You understand what I'm doing here, right? So see, we have this one, right? This node data is 10 and next is null, right? So this new node is exactly this one. So new node dot next means here this pointer will point to the head now. So you're gonna point to the head because you have head already here, right? You have the head object already. So just point to that head, okay? So new node dot next to this dot head, right? So you just call that head object. Basically there will be always head, right? Because we are creating, when you call this let's say when you create the instance from this constructor, you're gonna get head always. There will be always head. Right now null, right? So when you say new node dot next equal to this dot head means you're pointing to this head now, this object, okay? And again this object dot this, and then again you change the head, right? This dot head equal to new node now. That's it. That is because it's like a little bit the pointer will be pointing to the head, and now the head you assign the new object right here. This object pointer will point to the head, and now to the head you assign the new node, that will be this data. So this is the format we have to follow. So like for example, right, for example I will comment this out, and okay, let's check here. So you have the instance already, right? If you go back here and you say linked list dot add, you have the function already add first, right? And it you have to pass data 10, correct? 10. So if you console log now, right, console dot log, let's call this linked list and see what we get. F5. So see, now you have the head, right? And head has already the node now, the new node. It did not give the details, but that node is what you added here, right, already. If you go back again and add the new node, for example, let's say add again maybe 20, right? Save and run this. So still head is pointing to the node, right? I mean there will be node, but this node has many node now. Second node also, okay? That node is pointing to the next node now, next node already. So anyway, yeah, let's because we don't have a printer function right now to print the whole details. We will check later, right? We'll check that later. But you have a head with the node already. That node is going to have the next node. Okay, right. So let's keep moving. Okay, let's keep moving from here. So what is the next function now, right? Add to the end. So what is that one? Add to the last, right? So there is some more code up to here, and I will explain that. So add to the last, it's the same function, okay? You're gonna call that function, and when you call the function, because when you're adding first you need to, with that data you're gonna create the new node, right? So we call our node constructor, we have new node. Now because you want to add the last to the last, right? So now here is the logic to think. Let me clean this up, right? Because when you need to add to the last, for sure, right, you have many nodes like this already, right? Okay, you have built, so here is the data and you are pointing to okay, maybe why not I make it little bit space. So you have already data, right? Data and node. So here is some value, and then you pointing to the next node, 5. That there is a pointer pointing to the next node, or maybe next, whatever pointer is, and 6 is the pointer pointing here. So if you want to add the last, right, what we have to do? So we have to check if the head is null or not. If there is head null, then you add to the head, right? Because here is the head, you add it here. If not, now you have to go from here, find in one by one, move to the last, right? Go to the last node. Soon you find the null, right? Then before that you add it here, the new node. Okay, you're gonna put the new node here. But to reach here you must traverse, right? Travel from the head, because the only way we can go to the end is you find the head, and from there keep moving, next. So we have to use some kind of loop and put some condition to get to the last, and when you find the last, then you put the new node there, attach it. So that is what we are going to do in this one. So we just get the data ready, the node is ready, and if there is head, right, I mean head is null, that means if there is no head, then just call this dot head equal to new node. If this dot head has nothing, means there is no data, then you attach this dot head to the new node and return. Okay, now we have to find the current position, but this is, there is already head with data, then this will not gonna work, so we move here now. So let's find the current position. Starting position is head, so this dot head. Okay, we found that node, right? This dot head. Now we're gonna do the while loop. So in while loop we put some condition. As long as, I mean, once you do this dot head, you're gonna get object like this, correct? You have the node already, like with the head and all that. So there will be data, and there will be, let's say 10 comma, and then next maybe, right, pointer, which is pointing to something. So this is a head one. Okay, this is the head, right? Head, starting point is head. So this dot head means you get this one, right? And inside everything is there, inside all is there, right? All the remaining data. So how you gonna move from here all the way, right? So here current dot next, so this is the current dot, current is this one, dot next means this next. As long as there is current dot next, right, true, then you keep changing the current value with the current dot next one. So first you are here current, then you're gonna move, next will be inside here. Now again you move to the next current until you find, until this is true, right? So when this becomes false, that means your current dot next will be the last node, and there you can attach, right, the new node. The new node is what? This one. See? So that's how you travel from head to the tail, to the last. So the last one is called tail, but this will check. So things looks crazy, but I mean, when you start, when you do a lot of practice with the object, you will understand, right? Okay, so because what I'm saying here, right, there is many, like data, let's say 30, and then you're gonna have the next again inside, correct? And this next gonna have again the next object, and there will be data, like a 40 whatever, and there will be next. Okay, so when next will be null, the last one has null, right? See, so when the current dot next is null, that becomes false. That means you are already in this, you are already here now in this pointer. Okay, and that current dot next is the last one. You put the node, you just attach that new node, and done. So that's how you put the item in the last node. So here you can attach the new node, right? That will be like that, and you know that node already have the data, maybe whatever you get, and then the next is null, right? Null, because that is what we build here, you know. See, because always our new node gonna have data and the pointer will be null, so that you attach to the last. Okay guys, so you just you know, just look at this, right? Try to read, maybe you can look at this, see how it is constructed. This will give you, right, some idea on how, you know, like you create the object in def, right? Okay, fine, so let me delete this. So done, that is done. So I will let's move now a little quick. So that function is done, right? That is finished. So we're gonna go to the next one. What is the next one? Okay, let's find the size, right? What is the length of your node? So that is here. So size function, so let's create a variable count. Now the current, because to find the size also you start from the head, and first you store the head object in the current variable. Then as long as there is a current, right? If there is a current, that is true, right? If there is true, then increase the count. So the current will be head. Okay, there is a head, fine. Then you go inside, count plus plus, now it become 1, and you keep moving, you know. Current now will be the next node, current dot next. So you just go inside, whatever the next pointer has the next node, right? So you move, you keep changing. So now it will check if there is a current again. Yeah, there is a next node, so it will go inside, increase the count, and finally when the current will be null, right? That means the next will be null value, then it will be stop, and you have the count of your node. So that is what you're gonna get, right? So if I go here, right, and I say console log console is dot, just call the count function now, simple, and see what I get. Okay, so it did not linked list dot count, right? Oh, sorry, size, not count, size function. I need to call the size function. Sorry guys, size. So because we added 2 item, right, it should give us 2. So look at that. Good. Okay, so what is the next function now? So adding at the index means you have the long linked list with many nodes. You want to add somewhere in the middle, or maybe in the start, in, but you have the index, right? There is a number and the data. So let's see how you can do that. So let's copy this and then I will explain. Okay, so this function is asking you to give the index and the data, right? Fine, but index, now the point here is, right, when we writing any function, and you have to, that index must be a valid, then we have to do some conditional check. If that index is less than 0, then that is wrong. If index is greater than the size of our linked list, that is also wrong. Then you just display the error, invalid index, and return from there, done. Because you please input the right index, right? So this index, with this checking, right, index will be always correct. If that index is not correct, you will not gonna pass this line of code, you will be thrown out, right? Okay, so let's say you have the valid index and also you have data. Now the next step is, with data you're gonna create the node. So we have the node constructor function. So it will create the new object, correct? Fine, so we got that. uh, yeah, so we have the new node now, right? Now it's time to insert in that particular index. But see, in the linked list there is no index, right? But we have a size. Okay, what is the size of our linked list? So we start from, like start from 1 2 3 like that, right? Or maybe 0. Okay, 0. Start from 0 1 2 3. Even start 1 or 0 is okay, right? Let's say 0. So if somebody supplied with the index 0, fine, then we know that is the first, right? That is the head. Okay, so new, this is the new node dot next. You just attach the head first, right, to that next, because this new node has what? Data and the next, right? To that next you connect your head first, this dot head, and then in the head you put that new node. Done. So it's just switching the, like let's say for example, right, this is the head, right, head, the first one. Okay, it has the data 20 and it has the pointer that is called next, or maybe p, whatever you call, right, whatever you put in the code. You want to add the new node here, right, here. I mean, it may be pointing already to other node, it's okay, right? But you want to attach in the 0 index. Let's say this is a 0 index, first one. So what's gonna happen, right? You have this new node, it has 100 data, and there is a next, right? This is a new node, so new node dot next. So new node is our object, correct? New node, node, right? De node dot next, because this is the object. You just get the next this pointer, right, equal to, because there is already head. How you access head? That is a, the object in the constructor. So this dot head. So what that means, this is pointing now here. See, this, it is just pointing right now. The pointing is just here, right? So now to the head, what gonna happen, right? To the head now, it's just pointing there, but to the head, this dot head, right, equal to new node, new node. Okay, so what happened now? The head, look at here, right? This head is had this object. So for your next point to this object, and then this whole thing now you move it here, now here, right, to the head. So see, this is pointing already here, and you just get to the back of the head, I mean here in the head, and done. So their link is already continuous building, there is already linked. So you have to point to that object first, and then to the head you just put this one, and the chain will be built there already. Okay, hope that is clear. So that is what happened here, right? And then done. Let's say index is maybe something else, right? Then you gonna have to travel now. So that's why we create current position is the head, and then we add a for loop, start from index 0 and index, because you want to stay before last index. Okay, so index -1 I plus plus, and then you keep moving with the current dot next. Current is the head, from head object, as long as this is true, right? This index is true, you will be keep changing, keep moving, you find the right current object. Okay, and then once you have this done, right, once you finish this loop, you have the right node already to the current variable. Now next new node dot next will point that current dot next, and current dot next will have the new node. Attach it. Same thing what we do with the head here. Same situation. So you just chaining the link, okay? Just changing the link, right? Because the whatever is the last, whatever is the index, right? You find the right position, the current element. That current element next, you know, you have to attach it to the new node next, and then there you put the new node. So for example, let's imagine you have long node, right? But you find the current one here, correct? You find the current node, right? Here is your current node, maybe whatever position you find. There is a value, right? And here is a pointer, and this is your new node, correct? New node. So here is a value, here is a pointer. So what is saying now, right? Your new node dot next will point to here, right? And you point here, right? And it is also pointing somewhere, okay? Something is pointing already here also, right? And then this pointer, into this pointer you just attach here, right? So attach this one. So current, this is the current dot next equal to new node. I know that is confusing, right? So look at here. New dot next, you call the current next, right? That pointer. Okay, and then the next current dot next position, you have this new node. So it's similar to what we did with the head, okay? It's the same thing. You have to switch the node, right? Because you know there is lot of connected node, you know. So it has to new node. Okay. So let's say new node, right? New node dot next, that is a pointer. Point to this current next. Okay. And then after, right? So this already connected here now, right? But in that next current dot next, you must put the object itself. You have to put the object, right? So because that has already something, okay? It has already something. That current dot next already have something, okay? So you have to switch now. You have to switch that to here, and that when that become empty, then you put this one, link it, right? Okay, so that was the part here. New node dot next will be current dot next pointer, and the current next pointer gonna have the new node. Okay, so that is the, what was that, inserting to certain index, right? Now remove from the first node, so that will be quick. So when you remove from the beginning, we just check first if there is head or not, right? If there is no head, then return it. If there is head, then this dot head equal to this dot head dot next, right? So because you want to remove, okay, let's take one example. Because you want to remove from the beginning, right? Just think like this. There is a head, correct? This is the head. Head is pointing to this one. Head, right? Head is pointing here right now. Now this object has the data and the next, right? Next. So it is also pointing to the other node. So there is a data and the pointer. You need to remove this one now, right? So head dot next, you just point here, okay, and this will be gone, right? So that is what is done. So this dot head equal to this dot head. So this dot head, see, this dot head dot next means this head has this object. So this dot head dot next means this one. So now the head is directly pointing to the next of whatever here, right? It will point here. So once you change the link, this will be lost. So that's why head next. So whatever there was the other object inside this head next, that will be get straight to the head now. Clear? So let's look at the next one, how to remove the last one. So okay, how to remove the last node, right? So let's get it. Okay. Go back to our constructor and keep adding here. So again, we're gonna check first if we have a head or not, because if there is nothing, right, that means there will be no head. Then we don't need to go check, right? There will be nothing to remove. So we just return. Else, first we get to the head pointer, head, grab that current node, and while there is current node dot next, right? So see now here, right? Look at here. As long as this is true, current node dot next is what? This current is the object, it's like this, right? That's the object. So that current is the object. It has the data and 20, and it has the what we put there, let's say what we have added, next, right? There is a next as a pointer, next. Okay, so this is the first one, right? So current dot next, this is current is the variable, it is the object, current dot next, and there is another object inside here. So there is a data and let's say 30, and there is another next. See, so current dot next, this one, and that is again object dot next, that is another object here, right? So it will be keep checking, right? As long as this is true, make the current to the current dot next. Okay, so the current will be keep changing this current, then again next current, and you get to the last, right? So when you done, that means current will be the last, and you just make it right. Current dot next will be null, means whatever is the last one, right, to that current you make it null. Okay, so means while okay, let's say current will be current dot next, fine, and then once this loop is finished, we have one object, right? And that object, because remember the reason we put this next, right? If there is a, it will be end, it gonna end before 1. Okay, that means it will end before 1. If there is no next, right, if there is last one don't have the next, then you will stay one behind. Okay, and that's why current dot next you make it null. That means one last node will be gone. Okay, that is the trick here. Okay. So let's go back and see what is the next one now. Remove at index, any index at somewhere from the middle you want to remove, then you can use this function. so remove at index. Okay, so any index, that means you're going to pass the index. Same thing, right? We check if that index is valid or not, less than 0 or greater than the size of our list. If that is true, then return the error and return out, right? Done. Index must be valid. Okay, now if index is 0, that means we need to remove the head, right? Whatever attached to the head. So this dot head equal to this dot head dot next, means to the head you just point the next one, head dot next. So this dot head has one object, right? And this dot head object has the next attachment. Just attach directly that one, so the first one will be gone. Okay, if the index is something else, then you have to find the start from the current node, that is this dot head, and then you keep looping. Basically, you just keep moving until you find the right index, right? You just loop until the index. Okay, size of the index, you're gonna get the current node or current basically element or object, right? By this loop will make sure you get the current one to that index position. And once you find the current one, then remove that one, right? So that has the next, that element has a next, right? So if there is true, current dot next is true, then uh, to this next, right, you attach the next current dot next, means if this is the current, right, let's like this, data is 30 and next will be something, let's say, so it has object. Okay, current dot next means we're just going to remove this one, right? Dot, so this is the next, this is the current dot next, and dot next you're going to get here, right? So basically you're going to this element, right, you're going to just omit something from the middle. Basically you're just getting the next element to the current one, so whatever in the middle object will be gone, right? Okay, so that is the removing at the index. It looks crazy, I mean, it's difficult to understand, but it's just the chaining, okay, how things are done, right? Linking to the next element. Okay, so let's look at the print, how we're going to print now, right, the whole list. So this is the last, where are we ending here, right? So the print, you get the head, right? Head, first element is the head, and then as long as there is current element, let's console log current dot data, right? Current dot data, and this loop will be keep moving with the next node. As long as there is current, you will be keep printing the data of each element, right? So that means you are printing the data of each node by just this loop. Okay, so if you go here and call the print and run this code, so you get that two value, right? Okay, so what we're gonna do now, we have this implementation. Let's copy this and implement all that and see what happened, right? So you have the remove, basically you have add, you can add all this again, right? So same thing what we did before, right? So now if you print, you just console log, right? So you have all this in the node now, all this data. Okay, so how you going to remove, you can remove top. So if you do that, right, it will be just remove the first one. So just check now, first one is what, 10, right? 10. So if I add here and now run the print, right, I should have Okay, something is not good. So add, okay, add first, we just added in the beginning, right? Okay, so this will be the first now, okay, because we added in the beginning 6, so 6 will be removed, right? So yeah, so 6 will be removed. So let's check now. Which one we remove from the top, right? So something is not correct. So you have 3, 5, 20, 10. I don't know why my console got stuck. Okay, let me run again and see. So 3, 5, add first, right? Remove from the top. Okay, let me comment this out, right? And then run. Okay, so the first one is 8, right? We got 8 on the top, but where is the 6? Why 6 is in the last, you know? Oh, okay, so sorry guys, because this is add to the last, right? Okay, so that is on the top. The first one is add first, right? And this is the last. Okay, so 8 is of course first, that's why 8 is removed. Okay, that from the top. Yeah, so 8 is gone, right? And then we have any index you want to add, you know, so you just find the index and give the new number, right? You can do that. So let's say here I will put the index maybe 6 and see what happened. Let's make it 100, right? And run this. So invalid index, okay, 6 is invalid. 0, 1, 2, 3, 4, 5, right? So I must make it 5. And now run. So see, the 5 was this, right? But we have also removed 1. Okay, so we removed already 1, so comment that out and run this. So it will be easy to count. Okay, so 0, 1, 2, 3, 4, 5, and that is the 5. So we added just before the 5 index, right? The 100. Okay, so I mean same thing now, right? You can see the remove at last, remove at something, you know, and print. If you want to print all, let's copy this, add it, yeah, remove last, and you can remove at certain index also, so you can test that. I will delete this. Let's add here. So remove at last, it will remove the last one first. It will remove at this index, 2 index, so index 0, 1, 2, right? That 5 will be gone. And then print, right, all that size. So see, the 5 is gone. Remove at last, index 2, right? So 2 was 5, that is gone. The last will be 6, yeah, that is also gone. And size is 5, right? So remaining size is 5. Okay guys, so that is all, you know, I mean, that is the linked list. You have to read and understand, right? So you know, this is all about constructor functions, creating objects, and the way linked list, the singly linked list work, right? That is what we have looked at. But there is doubly, there is circular, but this linked list you never going to use in your project. Okay, this is not used, right? But for a student to understand the JavaScript or any programming language, right, in depth, if you can implement this kind of logic or not. So that is mostly for the student testing student skill, right? So I will advise, when you guys get free, please practice, even that JavaScript problems, right, we had in the beginning, what we did. Everyone should complete that one with very good understanding, right? All the data types, variable, all the functions, array, object, all that one should be easily known, right? If you master that one, and you will understand this also easily, right? It's gonna take some time to basically navigate through all this, but it will be right. All that is just function, function, function. Okay, so I will just stop here, guys.